So this is a very short segment, but I do want to point out in the notes, it says, read a molecular view of elements. That's the title of the section. I don't usually like to lecture on it at this point. I don't think it helps us that much. But it is important that you go through and read how the formulas are related to the structures. We're kind of talking about it in terms of the formulas that we see, but the book likes to put these molecular representations, and that might be helpful for some of you, so it would be good if you read through some of that. Now, what we're going to do here for the rest of this short segment is talk about naming binary covalent or quote-unquote molecular compounds. So let's talk about a binary covalent compound. What does that mean? Let's break down the words, right? Binary means what? Two, right? Covalent or molecular is this type, all nonmetal, okay? So molecular or covalent means nonmetals only. And compound means two or more elements, right? Now, because it says it's binary, it just means it's two different elements in a compound together. And what I'm going to teach you how to do is how to name it and then write formulas from the names. This turns out to be one of the easiest things in the chapter. So I don't want you to freak out when we see all these terms. But you do have to memorize these prefixes. And the prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Really, if you wanted to do 11, then you would say 1 in 10. So you would say undeca. Unfortunately, it's not mono. So anyways, how do we use this information, right? I'll get back to this in a second. Xenon hexafluoride. So you have to know the symbols, right? So there's xenon. Hexa is, right, 6. So hexa being 6, that means the hex is in front of the fluoride. I mean, cats are jumping around everywhere. It's XEF6, like that. That would be the formula. What about naming P3O6? Sorry, I think my mic went up. There's 3 phosphoruses, right? So you would go like this. Tri, right here. Tri. And then you would write the element name, phosphorus. And now there's 6 oxygen, right? So it's hex. And then here's the deal. That's what this note means. For monoxide instead of monoxide, I don't know how you would say that, right? You drop the last prefix vowel. So if you have 2 vowels together, if you have this, you're going to drop this. So this is 6 oxygens, so that would be hexa. But because oxygen starts with a vowel and hexa ends with the vowel, we get rid of the A and we just say hexoxide. Okay? So basically, the naming and the writing go together. If you're going to write the formula, you read the element symbol and you write the number of that element that are in the formula. The only difficulty here is that you recognize the xenon, right, and the phosphorus. We write the full name of the element, and for the second element, the last one, right, we end it in IDE just like we do for anions. So if we see sulfur trichloride or NF3, what I would like you to do is go ahead and write the names. The one warning I will give you is we use this mono prefix, right, only for the second element. So if you have one of the first element, you just ignore it. So go ahead and write the formula for sulfur trichloride and then NF3. And we're back. So there's sulfur, right? S, and then trichloride, so Cl3. And then NF3 is nitrogen, not mono because it's the first element. Okay, so nitrogen trifluoride. And one of my pet peeves, and I mean, I know, really, is this. It's F-L-U-O-R-I-D, not F-L-O-U, because everybody wants to write this. All right, because you write flower. So it's not fluoride. And so there's no flour in fluorine, is the saying. So it's fluor instead of flour. All right, so pet peeve. I won't ridicule you in public if you do it. All right, so that's it for that segment. Next, we'll be talking about naming ionic compounds.